Okay, let's take a look at this practice test, get you ready for the test that's coming up. Again, in instructions here, show all work and thinking for each problem, just like normal. We always want to circle our answer, and this says round to the nearest hundredth if necessary. Hopefully that doesn't become the case with too many of these. But let's take a look at the instructions for this first couple of problems. It says give the most specific name for the angle relationship, write an equation for the relationship, then solve for x. So actually got to do three things. We first of all got to give a very specific name for it. We've got to write an equation, and then we've got to solve for x. We want to make sure that we do all three of those things. So you'll take a look at the first one. These are vertical angles because they're formed by two intersecting lines. So we give the name vertical. That's as specific a name as we can give for that. Remember, vertical angles are always congruent, so we're going to take this angle, which is 2 plus 3x, and set it to that angle, which is 62. And then we start solving this. So I'm going to move the 2 to the other side. By subtracting 2, we get 3x equals 60. Get the x completely by itself by dividing by 3, and we end up with x equals 20. On number 2, we take a look at this one. We notice that this is a straight line. Remember, on one side of a straight line, we've got 180 degrees. So the best name that we could give for these would be supplementary. They do happen to be next to each other, so they are adjacent, but the most specific name that we can give to these is that they're supplementary. So we're going to take this angle right here, 3x plus 18, add it to 93. So there's our 3x plus 18, add the 93. We put these together, we get 111. We start solving this equation like we normally would, so we're going to subtract 111 from each side. We get 3x equals 69, finish off by dividing by 3, and we get x equals 23. So again, you'll notice we've got the most specific name, we've got the equation that represents that relationship, and then we solved for whatever x is. All right, next one. You'll notice that this is a right angle right here, and then we've got two that are right next to each other. So yes, again, these are adjacent, but the most specific name we can give to these, because if there's 90 degrees over here, this one's also got to be 90 degrees. So we know that those would be complementary. So they've got to add up to be 90 degrees. So this is the name of the relationship. Here are those two angles added together to make the 90 degrees. We then just finish solving this, and we end up with x equals 8. So again, name, equation, what the value of x is. And then this last one, again, with adjacent, there's not a whole lot that we can do unless we've got some other relationship going on here. And most of the time we ended up with these being right next to each other, and we can go all the way around full circle. So if I start right here and go around, I get 296 degrees. But if then I combine it with that one and that one, these are adjacent and they add up to 360 degrees. That is the most specific name we can give for this set of angles. So we add those together. So here's the x minus 24, there's the 29, and there's the 296. And again, notice how I put all the like terms together here. We add those together, we get 301, finish solving this, and we get x equals 59. So hopefully those are pretty easy problems for you. Great equation solving review, really good problems there. This next one says find the missing angle. So you'll notice that we've got 80 here and 35 here. I really would like to see an equation on this. Remember, the angles inside a triangle always add up to 180 degrees. So I'd really like to see the fact that you're adding these together, adding it to this missing piece, and it equals 180 degrees. So when we finish solving this, we're going to subtract 115 because that's what the two of those equal together. And we end up with 65. So that's the missing piece there. Again, I know it seems like it's a little bit silly. Gosh, why can't we just add these together and subtract from 180? That's the right idea, but in the long run, you're going to run into things where if you represent that relationship as an equation and you get used to that now, you're going to be in much better shape in next year and the year after and so forth. Okay, this one right here, they only give us one angle. And then this has that little box in there, that little mark of the square. That means that's 90 degrees. So we're going to take 40 plus 90 plus whatever this missing piece is and set it equal to the 180 degrees because we know those three would have to add up to 180 degrees. Those add up to 130, so we're going to subtract from 130. That missing piece there, that missing angle is 50 degrees. Same type of thing here. We've got the 20, the 127, and then that missing piece there. We combine those together. That's 147. Subtract, and we get 33 degrees. So nice, clear work here. Circled the answer. There's no question what we think the answer is on each one of these. This one says find the area. It would be a really good idea if you wrote the formula for each one of these. Please do not just write down the answer. At least show where you plug this stuff in. So this is a triangle. Formula is 1/2 the base times the height. There's the 1/2. There's the base. There's the height. Multiply all those together, we get 16.4. And again, because this is meters times meters, this is going to be meters squared. Whenever we measure area, it's always in square units. So if it's meters, it's going to be meters squared. In this particular one right here on number 9, it's feet. So this is going to be feet squared or square feet. And again, this is a parallelogram, so it's going to be the base times the height. Now you'll notice that on this one right here, I kind of wrote it backwards. This is 39, that would be the base, and this would be the height. But you know, it really doesn't matter because multiplication is commutative. I am actually going to go ahead and change this one. I'm going to write 39 times 17. So we've got the base times the height there. That'll just look a little bit more uniform. So we get 663 square feet there. Number 10, trapezoid. You can see the formula for the area. 1/2, this is base 1 plus base 2. So I'm going to write B1 and B2 here just to make it clear. And then the height is the distance from top to bottom. Again, don't get caught in this trap of thinking that that's the height. That's not. That's called the slant height. Same thing over here. So again, there are 3 different numbers that could possibly represent the height. The one that we want is the perpendicular distance between the two of those. So it's that one that meets that base perpendicularly. So we're in good shape there. If we were to multiply those together, put them in our calculator, all that sort of stuff, we get 20.25 square feet. That does work out without any rounding or anything, I think. Okay, let's take a look at the 2 of these. Now notice we needed to know the formulas for each one of these areas up here, triangle, parallelogram, and trapezoid. You need to know the formulas for area and circumference of a circle. So please make sure you have those straight and don't forget them. They are right here. Okay, area is pi r squared and circumference is 2 pi r. So it says find the area first on this particular one, so let's go ahead and do that. It's going to be pi times whatever the radius is. In this case, you can see that that's the radius because it goes from the center out to the edge. So that's going to be 10 squared if we throw that in the calculator, or really we're just taking pi and multiplying it by 100 if you think of it. So we end up with 314.16. There is a little bit of rounding there, so make sure that you get that right. And again, we're taking the radius, which is in inches, and squaring that, so we have inches squared. Again, area is always measured in square units. For the circumference, we've got 2 pi r. We put the 10 right there, throw that in our calculator, and we get 62.83. Again, a little bit of rounding on that one. And since that's just a distance, that's in inches. The formula for area, pi r squared. You'll notice on this one that they give you the diameter, the distance all the way across. So what we need to do is we need to take 9 and divide it by 2. So that's going to lead us to the fact that the radius is 4.5. So we put it in the formula right here, pi times 4.5 squared. Again, you'll have some rounding on this one, 63.62 centimeters squared. And then 2 pi r for the circumference. 2 times pi times r, we get 28.27 centimeters. Okay, let's flip it over and take a look at the other side. We've now got some volume problems and some surface areas of prisms. These tended to be a little bit more difficult, especially the surface area, so we'll get to those in just a second down here on 15 and 16. Let's take a look at number 13. 13 says find the volume of the prism. You'll notice that we've got the general volume formula for a prism. It's that big capital B times H. That's the area of the base times the height. So the area of the base is this right here. We want to figure out how many squares we can fit along here. So that would be 7 times 10. We just find the area of that rectangle down there. 7 times 10, and then we times that by 5. We get 350 cubic inches. Remember, this is 10 inches times 7 inches times 5 inches. Inches times inches times inches. Easiest way to write that down would be cubic inches, inches cubed. Remember, we always measure volume in cubic units. This one right here is a triangular prism. It is set on its side, so again, we do have to recognize that this right here is that base. And again, if we were to kind of do some cross-sectional slices, we can see that we get that same shape all the way through. So when we say the volume is the area of the base times the height, we need to find the area of that triangle right there, which is this same triangle here, which is that same triangle there. Now you'll notice that they put the measurements over here, but they put an important piece over here. That is a right angle. So we have a base and a height right there. So the area of that triangle is 1/2 the base times the height. So that's going to be 1/2 of 8 times 6. And then we multiply how tall it is, or how long it is. That would be this 12 right here. When we multiply those together, we get 288 cubic meters. Okay, let's take a look at these next ones. Let's see, find the surface area of each prism. Okay, so I did this 2 different ways. I want you to take a look. I drew a net, which I know some people like. And then I also did it another way. I'm going to talk about that in just a second. So here's what we did. We cut this along here. Remember that idea of kind of taking a can opener? We're going to cut the top off, cut the bottom off the same way, and then we're going to flip it open, and then we'll cut along right here. So what happens is this side right here, this 10 by 4 goes right here. I'll actually put a 4 right there. And then we flip up the top, that's 10 by 17, it goes up here, flip down the bottom, it's right here, and then we just kind of unroll that side right there. So if this is 10, that's going to be 10, if this is 10, that's going to be 10, and then we've got that alternating pattern, 10, 17, 10, this front side's got to be 17, I've got all those marks there. So if you want to do it that way, that's fine. I also did it this way. I cut the top off and cut the bottom off, so I have 2 of these right here. And then the side, if you just kind of run that out, it looks like this. This is going to be 10, this is going to be 17, this is going to be 10, this is going to be 17. So altogether that adds up to 54. So a couple different ways of looking at this one right here. Either way, when we multiply these together, we get 170. Double it, we get 340. When we do 54, because that's how long this entire side is, it's 54 wide and then 4 tall. So when we multiply those together, we get 216. Add those together, we get 556 square meters. And then same type of thing here. I drew a net for this. Cut it along here, here, and then here. So kind of flip the back down, that triangular back, flip that triangular front down, and then just kind of split the sides of the tent open. Looks like this. We have a big rectangle for the sides, which are going to be 14 tall, and then 5 and 8 and 5. That's going to be 18. So here's that rectangle that represents the side that's 14 tall and 18 wide. If you multiply those together, we get 252 for the sides. And then we've got 2 of those triangles front and back there. So the formula for the area of a triangle is 1/2 the base times the height of 6. And again, we're going to have 2 of those. So those kind of cancel out. We get 48 here. Add those together, we get 300 square feet altogether. Okay? All right. These next 2, now I will tell you this. I think the test on this is actually a little bit shorter, maybe a little bit easier than what the practice test is here, because we've done some volume up here on 13 and 14. We've done some surface area on 15 and 16. So let's take a look at number 17 and 18. They say find the volume and the surface area. So the volume is simply the area of the base times the height. So that's going to be length times width times height. We multiply those together, we get 194.4. Because this is in centimeters, this is going to be centimeters cubed, remember, because it's a volume. And then on this one I did it a little bit differently. Instead of drawing a net for this, I said, okay, I've got 2 tops and bottoms. So I've got a bottom that is 7 by 3 and a top that's also 7 by 3. So I've got 2 of those. So I'm going to do 7.2 times 3. So 7.2 times 3, that's the area of a top or bottom, and then I double it to get both of them. I've got a left and a right. If you take a look at these are 3 by 9. So there's the left side and here's the right side. So 3 times 9, and if I double that, I end up with 54. And then I've got a front and a back. The front is 9 tall and 7.2 wide. So that's going to be 7.2 times 9. And again, we've got a front like that and a back like that. Multiply those together, add the answers for the area of each one of those sets of sides up, and we get 226.8 centimeters squared. Okay, let's take a look at number 18, another triangular prism. And what I did here is I said, okay, we're going to take this and we're going to cut it right here. We're going to take the top and the bottom off, so we've got 2 of these, and notice that we've got to have this side right here. How long is that edge? That edge is the same as up here, so it's going to be 5 wide and 1.5 tall. So the area is going to be 1/2 that base, which is 5, times the height, which is 1.5. Multiply those together. Remember, we've got 2 of them, so we end up with 7.5 if we throw that into our calculator. And then the sides, I've got this, every single one of them is 4 tall, 4 yards tall. Okay, and then I've got 2 here, 5 here, and 4 here. So what we're doing is we're kind of cutting it along here and figuring out, okay, how far would it be from here to here? Well, that's 2, that's 5, and that's 4. So 2, 5, and 4, add those up, that's 11. So we get 4 times 11 is 44. Add that to the top and the bottom, and we get 51.5 square yards. Okay, that's the surface area, and then I also did the volume. So we find the area of that base, the area of that triangle, which is going to be 1/2 of 5 times 1.5 is the height. So that's the area of the base. And then how tall can you stack them? You can stack them 4 tall. So we're going to do all of that multiplied together. We end up with 15 cubic yards. Remember, we're finding a volume there. Okay, now these last couple of problems, I don't think we've seen anything exactly like this, but I think these are perfectly fair game. Because if you understand fundamentally what's going on with these, if you really get this, you're going to be able to do these. So this triangle, or sorry, this composite figure right here is cut up into a bunch of triangles and rectangles. And they're actually, I mean, they're already set up for you. So I want you to notice something. This triangle has a right angle right here, and it's 4.3 kilometers wide. This right here is the slanted height of that triangle right there. So we don't use that slanted height. We need to know what this one is right here. Well, it's the same as this one right here, 9.3. So it's 4.3 by 9.3, and then we have two of them. We've got one here and one there. So that's why we're going to do 2 times those. So 2 times 1/2 times the base times the height. So we get 39.99. We've got that rectangle right here already broken up for us. So that is 18.1 kilometers long and 9.3 tall. So we multiply those together, we get 168.33. And then we've got this triangle down here on the bottom. I probably wouldn't do it as 2 separate pieces. I'd probably just do it as one. It's 18.1 long and then 9 tall. So this is going to be like our base, and that's going to be like our height. So 1/2 the base times the height. Multiply those together, we get 81.45. So if I put this, this, and this together, add those all up, we get 289.77 square kilometers. So there's our answer for that one, the area of that composite figure. And then this last one says find the volume and the surface area. Now, we have not done one like this. It would be interesting if you could come up with a name for this. This is a prism. It is a special type of box. And take a look at the base right here. Okay, we've got this shape right here, and I know that's the base because if I were to slice it parallel to that again, I get that shape there. Well, remember what that shape that is. If the top and bottom are parallel but the 2 other sides are not, this is called a trapezoidal prism. A trapezoidal prism. So the volume is just going to be the area of the trapezoid, which is going to be 1/2 of B1 plus B2, so 1/2 of 4 plus 12. Times the height of 6, okay? So that's the area of the base, and then we want to know how tall it is, how deep we could stack squares there. So we multiply by 5, we end up, once we do all the simplification everything, we get 240 cubic feet. Great problem to really stretch your thinking. Probably wouldn't be a test question unless it was maybe like a bonus or something like that, but I think you'll be in good shape with those. And then same type of idea when we're dealing with surface area. Let's take this and let's cut along here with a can opener, cut along there with a can opener, and then we'll just split it open right there. And if we lay the sides out, we get that rectangular shape that we're familiar with. We flop open the top, or let's call it the front and the back, and we get these trapezoids right here. So we have 2 of those trapezoids, 1/2 B1 plus B2 times the height. We get 2 of those, so we get 96 right here. And then if you add up how far it is all the way around that trapezoid, we get 8 and 12 and 7 and 4. So let's follow that. 8 and 12 and 7 and 4. So when we multiply those together with how wide that side piece is, we get 151 square feet. So we add the 2 of those together, we get 251 square feet. So good little workout, fair number of problems there. If you can do this, you'll be in really, really good shape for the test. So good luck as you study.